Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You plan to deploy your cloud infrastructure using a CI/CD cluster hosted on Compute Engine. You want to minimize the risk of its credentials being stolen by a third party. What should you do? The options are: Option A, create a dedicated cloud identity user account for the cluster. Use a strong self-hosted vault solution to store the user's temporary credentials. Option B, create a dedicated cloud identity user account for the cluster. Enable the constraints/IAM. Disable service account creation organization policy at the project level. Option C, create a custom service account for the cluster. Enable the constraints/IAM. Disable service account key creation organization policy at the project level. Option D, create a custom service account for the cluster. Enable the constraints/IAM. Allow service account credential lifetime extension organization policy at the project level.
To arrive at the correct answer, we focus on the keywords CI/CD cluster hosted on Compute Engine, minimize the risk of its credentials being stolen.
The correct answer is option C, create a custom service account for the cluster. Enable the constraints/IAM. Disable service account key creation organization policy at the project level.
Why is this correct? C. Using a custom service account enforces least privilege. Disabling service account key creation ensures long-lived external keys cannot be generated, forcing reliance on secure, short-lived tokens natively attached to Compute Engine, thus minimizing the risk of credential theft. Why are the others incorrect? A. Compute Engine instances should use service accounts for automated tasks, not cloud identity user accounts which are for humans. Storing user credentials in a vault adds unnecessary risk and complexity. B. Cloud identity user accounts are meant for human users, not automated services. Disabling service account creation prevents you from implementing the best practice of using custom service accounts. D. Allowing service account credential lifetime extension increases the risk, because if a credential is stolen, it could potentially be used for a longer period of time.
Your organization must comply with the regulation to keep instance logging data within Europe. Your workloads will be hosted in the Netherlands in Region Europe West 4 in a new project. You must configure cloud logging to keep your data in the country. What should you do? The options are: Option A, configure the organization policy constraint GCP.resource locations to Europe West 4. Option B, configure log sync to export all logs into a cloud storage bucket in Europe West 4. Option C, create a new log bucket in Europe West 4 and redirect the _default bucket to the new bucket. Option D, set the logging storage region to Europe West 4 by using the Cloud CLI logging settings update.
To arrive at the correct answer, we focus on the keywords: keep instance logging data within Europe, Region Europe West 4, configure cloud logging to keep your data in the country.
The correct answer is option C, create a new log bucket in Europe West 4, and redirect the _default bucket to the new bucket.
Why is this correct? C. Creating a regional log bucket in Europe West 4 and redirecting the _default sync to it ensures that cloud logging natively stores all ingested logs exclusively in the specified location, fulfilling data residency compliance. Why are the others incorrect? A. The GCP.resource locations organization policy constraint restricts where new resources can be deployed but does not inherently control or migrate the storage region of cloud logging buckets. B. Exporting logs to a cloud storage bucket creates a localized copy, but cloud logging still retains the original logs in the _default bucket, which may be located outside the required region. D. The cloud logging settings update command sets default storage locations for organizations or folders. It does not configure or redirect an individual project's default logging bucket to a new region.
Your company's Google Cloud organization has about 200 projects and 1,500 virtual machines. There is no uniform strategy for logs and events management, which reduces visibility for your security operations team. You need to design a logs management solution that provides visibility and allows the security team to view the environment's configuration. What should you do? The options are: Option A, 1. Create a dedicated log sync for each project that is in scope. Point 2. Use a BigQuery dataset with time partitioning enabled as a destination of the log syncs. Point 3. Deploy alerts based on log metrics in every project. Point 4. Grant the role monitoring viewer to the security operations team in each project. Option B, 1. Create one log sync at the organization level that includes all the child resources. Point 2. Use as destination a pub/subtopic to ingest the logs into the security information and event management (SIEM) on premises and ensure that the right team can access the SIEM. Point 3. Grant the viewer role at organization level to the security operations team. Option C, 1. Enable network logs and data access logs for all resources in the production folder. Point 2. Do not create log syncs to avoid unnecessary costs and latency. Point 3. Grant the roles logs viewer and browser at project level to the security operations team. The remaining options are: Option D, 1. Create one sync for the production folder that includes child resources and one sync for the logs ingested at the organization level that excludes child resources. Point 2. As destination, use a log bucket with a minimum retention period of 90 days in a project that can be accessed by the security team. Point 3. Grant the security operations team the role of security reviewer at organization level.
To arrive at the correct answer, we focus on the keywords: Google Cloud Organization, no uniform strategy for logs and events management, design a logs management solution, view the environment's configuration.
Correct answer is option B, 1. Create one log sync at the organization level that includes all the child resources. Point 2. Use as destination a pub/subtopic to ingest the logs into the security information and event management (SIEM) on premises, and ensure that the right team can access the SIEM. Point 3. Grant the viewer role at organization level to the security operations team. Review the options on screen.
Why is this correct? B. An organization-level log sync efficiently aggregates logs from all projects. Exporting to SIEM via pub/sub is standard for centralized management. The viewer role at the organization level allows the security team to view configurations globally without granting modifying permissions. Why are the others incorrect? A. Creating dedicated syncs per project across 200 projects is an operational burden and not a uniform strategy. Also, monitoring viewer does not grant permissions to view all resource configurations. C. Not creating log syncs fails the requirement to design a logs management solution. Granting project-level roles across 200 projects lacks uniformity and scalability. D. Creating a sync only for the production folder leaves other projects unmonitored, failing the full visibility requirement. Security reviewer is generally focused on IAM rather than complete resource configurations.
Your organization is deploying a new web application on Compute Engine and needs robust perimeter security. You need to protect the application from common web attacks, including SQL injection and cross-site scripting, XSS, while also controlling network traffic based on the source IP address and user identity. What should you do? The options are: Option A, implement cloud load balancing and cloud DNS. Set up cloud CDN to cache content and mitigate some DDoS attacks. Configure Cloud Armor to provide Layer 7 protection. Option B, deploy Cloud Armor with its default WAF rules enabled. Configure network firewall rules on the Compute Engine instances to control all traffic based on source IP addresses. Use Cloud IAM to manage which users have roles granting access to the web application. Option C. Use Google Cloud Armor with pre-configured WAF rules to filter malicious traffic. Implement VPC Service Controls to create a secure perimeter around the application's resources. Manage users with Cloud IAM. Option D. Deploy Cloud Armor and configure cloud firewall rules to control traffic based on source IP addresses. Integrate with identity-aware proxy to control access based on user identity.
To arrive at the correct answer, we focus on the keywords, protect the application from common web attacks, including SQL injection and cross-site scripting, XSS, controlling network traffic based on the source IP address, user identity.
The correct answer is option D, deploy Cloud Armor and configure cloud firewall rules to control traffic based on source IP addresses. Integrate with identity-aware proxy to control access based on user identity.
Why is this correct? D. Cloud Armor mitigates web attacks, SQL, XSS. Cloud firewall rules restrict traffic by source IP. Identity-aware proxy, IAP, specifically handles access control based on user identity, meeting all stated requirements perfectly. Why are the others incorrect? A. Cloud load balancing and Cloud Armor address web attacks and DDoS, but this option completely fails to address controlling access based on user identity. B. Cloud IAM manages administrative permissions for Google Cloud resources, not end-user authentication or authorization for web applications. Identity-aware proxy is required for the latter. C. VPC Service Controls protect Google Cloud APIs against data exfiltration, not end-user application access. Also, Cloud IAM is not suitable for managing web application user identity.
Your organization is building an application powered by generative AI that uses sensitive internal data to train the AI model. The application is built using Vertex AI, which is generally available in your region. You must ensure Google does not use your sensitive data when tuning public models because it could result in your data being shared with other Google Cloud customers. What should you do? The options are: Option A. Do not use Vertex AI for sensitive data. Use only public data with minimal privacy requirements. Option B. Encrypt your data by using customer-managed encryption keys, CMEK, to have full control over encryption key access. Option C. Do nothing. Vertex AI foundation models are frozen by default and do not use your data for model tuning purposes. Option D. Contact Google support to opt out of model tuning.
To arrive at the correct answer, we focus on the keywords, sensitive internal data, Vertex AI, ensure Google does not use your sensitive data when tuning public models.
Correct answer is option C, do nothing. Vertex AI foundation models are frozen by default and do not use your data for model tuning purposes.
Why is this correct? C. Vertex AI foundation models are frozen by default. Google does not use customer data to train or tune its public foundation models, ensuring your data remains private. Why are the others incorrect? A. Vertex AI includes strong data privacy controls for enterprise use, so there is no need to avoid using it for sensitive data. B. While CMEK encrypts data at rest, it does not govern model tuning policies or prevent data usage for training. D. There is no need to contact Google support to opt out because customer data is excluded from public model tuning by default.
Your company is migrating a 3-tier web application to Google Cloud. The application consists of a web frontend, an application backend, and a database. Due to regulatory requirements and existing on-premises infrastructure dependencies, you need to implement a hybrid cloud architecture. The web frontend will be hosted on Google Cloud, while the application backend and the database will remain on-premises initially. You need to ensure secure and efficient communication between the cloud-based frontend and the on-premises backend and database, minimizing latency and maximizing availability. What should you do? The options are: Option A, establish a dedicated interconnect connection between the Google Cloud VPC network and the on-premises network. Configure firewall rules to allow communication between the three tiers. Option B, establish a direct internet connection between the Google Cloud VPC network hosting the web frontend and the on-premises network that hosts the backend and database. Configure firewall rules to allow communication between the three tiers. Option C, replicate the on-premises backend and database to Google Cloud. Use a hybrid connectivity network endpoint group for the primary. Backup to the zonal network endpoint group. Option D, use a highly available Cloud VPN connection over the public internet to connect the Google Cloud VPC network to the on-premises network.
To arrive at the correct answer, we focus on the keywords: hybrid cloud architecture, secure and efficient communication, minimizing latency, maximizing availability.
The correct answer is option A, establish a dedicated interconnect connection between the Google Cloud VPC network and the on-premises network. Configure firewall rules to allow communication between the three tiers.
Why is this correct? A. Dedicated interconnect provides private, highly available, low latency, and high bandwidth connectivity, fulfilling the requirements for secure and efficient hybrid communication between the tiers. Why are the others incorrect? B. A direct internet connection exposes sensitive inter-tier traffic to the public internet, compromising security, and cannot guarantee low latency or high availability. C. Replicating the backend and database to Google Cloud violates the explicit regulatory requirement that they must remain on-premises initially. D. While secure, Cloud VPN traverses the public internet, which cannot guarantee the minimized latency required for efficient inter-tier communication compared to dedicated interconnect.
You are implementing data protection by design and in accordance with GDPR requirements. As part of design reviews, you are told that you need to manage the encryption key for a solution that includes workloads for Compute Engine, Google Kubernetes Engine, Cloud Storage, BigQuery, and pub/sub. Which option should you choose for this implementation? The options are: Option A, Cloud External Key Manager. Option B, Customer Managed Encryption Keys. Option C, Customer Supplied Encryption Keys. Option D, Google Default Encryption.
To arrive at the correct answer, we focus on the keywords: GDPR requirements, manage the encryption key, Compute Engine, Google Kubernetes Engine, Cloud Storage, BigQuery, and pub/sub.
The correct answer is option A, Cloud External Key Manager.
Why is this correct? A. Cloud External Key Manager, EKM, helps satisfy strict GDPR data sovereignty requirements by keeping keys in an external system outside Google Cloud. It supports all the specified services: Compute Engine, GKE, Cloud Storage, BigQuery, and pub/sub. Why are the others incorrect? B. Customer Managed Encryption Keys, CMEK, are stored within Google Cloud KMS. While offering control, it does not provide the absolute external separation required by strict GDPR interpretations that Cloud EKM offers. C. Customer-supplied encryption keys, CSEK, are not supported by all the required services in the workload, such as pub/sub and BigQuery, making it an invalid choice for this specific architecture. D. Google Default Encryption means Google manages the keys on your behalf. This violates the explicit requirement that you need to manage the encryption key yourself.
You are tasked with exporting and auditing security logs for login activity events for Google Cloud Console and API calls that modify configurations to Google Cloud resources. Your export must meet the following requirements: export related logs for all projects in the Google Cloud organization. Export logs in near real time to an external SIEM. What should you do? Choose 2. The options are: Option A, create a log sync at the organization level with a pub/sub destination. Option B, create a log sync at the organization level with the include children parameter and set the destination to a pub/sub topic. Option C, Enable data access audit logs at the organization level to apply to all projects. Option D. Enable Google Workspace audit logs to be shared with Google Cloud in the admin console. Option E. Ensure that the CIAM processes the authentication info field in the audit log entry to gather identity information.
To arrive at the correct answer, we focus on the keywords, login activity events, API calls that modify configurations, all projects in the Google Cloud organization, near real-time to an external CIAM.
The correct answers are option B, create a log sync at the organization level with the include children parameter, and set the destination to a pub/sub topic. And option C, enable data access audit logs at the organization level to apply to all projects.
Why is this correct? B. An organization-level log sync with the include children parameter ensures logs from all underlying folders and projects are exported. Pub/sub provides the required near real-time log delivery to the external CIAM. C. Enabling data access audit logs at the organization level ensures that necessary detailed access logs and API calls are comprehensively recorded and applied uniformly across all projects. Why are the others incorrect? A. An organization-level log sync without the include children parameter will only capture logs generated directly at the organization node, missing the logs from the individual projects. D. Google Workspace audit logs are not relevant for tracking Google Cloud Console logins or Google Cloud API configuration changes as described in the scenario. Why are the others incorrect? E. Processing the authentication info field in the CIAM is an operational detail that does not fulfill the foundational requirements of configuring the log export across all projects.
Which two security characteristics are related to the use of VPC peering to connect two VPC networks? Choose two. The options are Option A, central management of routes, firewalls, and VPNs for peered networks. Option B, non-transitive peered networks, where only directly peered networks can communicate. Option C, ability to peer networks that belong to different Google Cloud organizations. Option D, firewall rules that can be created with a tag from one peered network to another peered network. Option E, ability to share specific subnets across peered networks.
To arrive at the correct answer, we focus on the keywords, security characteristics, VPC peering, connect two VPC networks.
The correct answers are option B, non-transitive peered networks, where only directly peered networks can communicate, and option C, ability to peer networks that belong to different Google Cloud organizations.
Why is this correct? B. VPC network peering connections are strictly non-transitive. Only directly peered networks can communicate, which prevents unintended hop-through traffic to other networks. C. Google Cloud supports VPC network peering between networks belonging to completely different organizations, allowing secure cross-organizational resource communication. Why are the others incorrect? A. VPC network peering does not offer centralized administration. Each peered VPC network retains independent control over its own routing tables and firewall rules. D. Network tags cannot be referenced in firewall rules across peered networks. Tags are only valid for traffic control within a single VPC network. E. When VPC networks are peered, all subnet routes are automatically exchanged. You cannot configure the peering to only share specific subnets.
In order to meet PCI DSS requirements, a customer wants to ensure that all outbound traffic is authorized. Which two cloud offerings meet this requirement without additional compensating controls? Choose two. The options are Option A, App Engine. Option B, Cloud Functions. Option C, Compute Engine. Option D, Google Kubernetes Engine. Option E, Cloud Storage.
To arrive at the correct answer, we focus on the keywords, PCI DSS requirements, all outbound traffic is authorized, without additional compensating controls.
The correct answers are option C, Compute Engine, and option D, Google Kubernetes Engine.
Why is this correct? C. Compute engine instances run within a virtual private cloud, VPC, which natively supports egress firewall rules to restrict and authorize all outbound traffic without requiring additional controls. D. Google Kubernetes Engine nodes operate within a VPC network, allowing you to natively apply VPC egress firewall rules and network policies to control all outbound traffic. Why are the others incorrect? A. App Engine requires additional compensating controls, such as serverless VPC access connectors, to route and restrict outbound traffic through VPC firewall rules. B. Cloud Functions requires extra compensating controls like serverless VPC access to manage and restrict its egress traffic via a VPC network. E. Cloud Storage is a managed object storage service that does not act as a source of general outbound network traffic requiring egress firewall authorization.
Your organization is using AI to improve products through innovation. The developers want to use Gemini and Vertex AI on a project. You need to provide a secure Google Cloud environment to prevent and detect information leakages. What should you do? The options are: Option A, set up VPC Service Controls perimeters around the Vertex AI project. Enable Data Loss Prevention API for content inspection. Option B, grant the developers and AI engineers the Vertex AI user role. Monitor the audit trails with cloud logging. Option C, deploy Model Armor to protect the Vertex AI endpoint. Review Security Command Center findings to detect information leakages. Option D, implement a firewall rule that allows all traffic to and from the Vertex AI API endpoint.
To arrive at the correct answer, we focus on the keywords Gemini and Vertex AI, prevent and detect information leakages.
The correct answer is option C, deploy Model Armor to protect the Vertex AI endpoint. Review Security Command Center findings to detect information leakages.
Why is this correct? C. Model Armor is specifically designed to protect Vertex AI endpoints by inspecting generative AI prompts and responses for sensitive data, preventing information leakages. Security Command Center natively integrates with Model Armor to detect and manage these findings. Why are the others incorrect? A. VPC Service Controls protects the network perimeter but does not inspect AI prompt or response content for sensitive data. Cloud DLP requires custom integration, unlike Model Armor, which is purpose-built. B. IAM roles and cloud logging provide access control and audit trails, but they do not proactively inspect content to prevent or detect information leakages within generative AI interactions. D. Allowing all traffic to and from the endpoint increases your attack surface and provides absolutely no mechanism to prevent or detect information leakages.
You are responsible for configuring identity and access management in your organization's Google Cloud environment. You need to restrict your organization's users from accessing cloud storage buckets in other Google Cloud organizations. What should you do? The options are: Option A, set a principal access boundary policy with the appropriate enforcement version. Bind the policy to the principles of your organization. Option B, configure organization restriction headers for your environment. Only include the organization ID of your organization in the list of allowed resources. Option C, create an IAM deny policy on the organization level that prevents access to cloud storage buckets outside the organization. Option D, enforce domain restricted sharing in your organization. Configure a managed constraint, and only include the principals in your organization.
To arrive at the correct answer, we focus on the keywords restrict your organization's users from accessing cloud storage buckets in other Google Cloud organizations.
The correct answer is option A, set a principal access boundary policy with the appropriate enforcement version. Bind the policy to the principles of your organization.
Why is this correct? A. Principal access boundary (PAB) policies restrict the resources that principals can access, regardless of their IAM permissions. This is the correct mechanism to prevent your organization's users from accessing resources in external organizations. Why are the others incorrect? B. Organization restriction headers restrict access based on the network environment, e.g., using proxies or VPC service controls, not by directly binding policies to IAM users. C. IAM deny policies are evaluated on resources within the organization where they are applied. They cannot be used to restrict access to resources located in other organizations. D. The domain restricted sharing constraint restricts which external identities can be granted access to your resources. It does not control where your users can access resources.
Your global defense company is migrating top-secret classified data to BigQuery and cloud storage. National security regulations demand that master encryption key material never leaves the accredited on-premises cryptographic hardware. You must retain the unilateral ability to revoke data access, independent of any cloud provider. What should you do? The options are: Option A, use customer-managed encryption keys, CMEKs, for the BigQuery datasets and cloud storage buckets. Store the keys in Cloud Key Management Service, Cloud KMS. Option B, use customer-supplied encryption keys, CEKs, by providing your own encryption keys with each data operation in cloud storage and BigQuery. Option C, import existing on-premises master encryption keys into Cloud Key Management Service, Cloud KMS. Use the imported keys for BigQuery and cloud storage encryption. Option D, configure Cloud External Key Manager, Cloud EKM, for the BigQuery datasets and cloud storage buckets. Integrate EKM with your existing on-premises hardware security modules, HSMs.
To arrive at the correct answer, we focus on the keywords: master encryption key material never leaves the accredited on-premises cryptographic hardware, retain the unilateral ability to revoke data access, independent of any cloud provider.
The correct answer is option D, configure Cloud External Key Manager, Cloud EKM, for the BigQuery datasets and cloud storage buckets. Integrate EKM with your existing on-premises hardware security modules, HSMs.
Why is this correct? D. Cloud EKM allows you to protect Google Cloud data using keys stored and managed in your on-premises HSMs. The key material never leaves your infrastructure, enabling unilateral revocation of data access. Why are the others incorrect? A. Using CMEK within Cloud KMS stores the master encryption keys within Google Cloud, violating the requirement that key material never leaves the on-premises hardware. B. CSEK requires sending the key to Google Cloud for data operations. Additionally, CSEK is not broadly supported for BigQuery data at rest, making it unsuitable for this scenario. C. Importing keys to Cloud KMS transfers the master key material into Google Cloud. This explicitly violates the requirement that the key never leaves the on-premises cryptographic hardware.
Your organization relies heavily on virtual machines, VMs, in Compute Engine. Due to team growth and resource demands, VM sprawl is becoming problematic. Maintaining consistent security hardening and timely package updates poses an increasing challenge. You need to centralize VM image management and automate the enforcement of security baselines throughout the virtual machine lifecycle. What should you do? The options are: Option A, use VM Manager to automatically distribute and apply patches to YMs across your projects. Integrate VM Manager with hardened, organization-standard VM images stored in a central repository. Option B, configure the sole tenancy feature in Compute Engine for all projects. Set up custom organization policies in Policy Controller to restrict the operating systems and image sources that teams are allowed to use. Option C, create a cloud build trigger to build a pipeline that generates hardened VM images. Run vulnerability scans in the pipeline, and store images with passing scans in a registry. Use instance templates pointing to this registry. Option D, activate Security Command Center Enterprise. Use VM discovery and posture management features to monitor hardening state and trigger automatic responses upon detection of issues.
To arrive at the correct answer, we focus on the keywords: maintaining consistent security hardening, timely package updates, centralize VM image management, automate the enforcement of security baselines.
The correct answer is option A. Use VM Manager to automatically distribute and apply patches to VMs across your projects. Integrate VM Manager with hardened, organization standard VM images stored in a central repository.
Why is this correct? A. VM Manager provides automated patch management, configuration management, and inventory tracking for compute engine instances, effectively solving the need for timely updates and centralized security baseline enforcement across the VM lifecycle. Why are the others incorrect? B. Sole tenancy only provides physical hardware isolation, which does not address the need for OS package updates, image management, or ongoing security baseline enforcement inside the VMs. C. Although building a pipeline creates hardened initial images, this approach lacks a mechanism for applying ongoing, timely package updates to running VMs throughout their lifecycle. D. Security Command Center provides visibility and posture management but does not include native OS patch management or centralized VM image lifecycle management like VM Manager.
A company migrated their entire data/center to Google Cloud Platform. It is running thousands of instances across multiple projects managed by different departments. You want to have a historical record of what was running in Google Cloud Platform at any point in time. What should you do? The options are: Option A, use Resource Manager on the organization level. Option B, use Forseti Security to automate inventory snapshots. Option C, use Stackdriver to create a dashboard across all projects. Option D, use Security Command Center to view all assets across the organization.
To arrive at the correct answer, we focus on the keywords: thousands of instances across multiple projects, historical record of what was running in Google Cloud Platform at any point in time.
Correct answer is option D. Use Security Command Center to view all assets across the organization.
Why is this correct? D. Cloud Security Command Center includes Cloud Asset Inventory, which natively provides organization-wide visibility and maintains a historical record of resources, allowing you to view exactly what was running at any specific point in time. Why are the others incorrect? A. Resource Manager is used to logically organize and manage access to resources hierarchically via organizations, folders, and projects, but it does not maintain a historical inventory of running instances. B. While Forseti Security can take inventory snapshots, Cloud Security Command Center is the fully managed, native Google Cloud service designed to automatically track and provide historical records of all organizational assets. C. Stackdriver, now Cloud Operations, creates dashboards for metrics, logs, and diagnostics. It is used for performance monitoring rather than providing a comprehensive historical inventory of all deployed cloud resources.